In this video, we're continuing section 1.5 on solving equations, and we are ready for rule 8 of solving equations, which says that if we have an equation that has a variable inside of an absolute value, we want to isolate the absolute value first, and when we do that, we're going to get something like this. So the absolute value, and maybe we'll have some stuff inside of it on one side of the equation, and some other junk on the other side of the equation. Okay, so when we get our equation with the absolute value to a form like this, well, then what do we do to solve it? So let's look at a simple example to kind of motivate the idea. So if I had absolute value of x equals 3, well, what could x possibly be? There's one of two possibilities. So x could either be 3 or x could be -3. In other words, the stuff that's inside of the absolute value could either be this junk on the right, or it could be equal to the negative of the junk. Okay, so let's use this idea now to solve a more complicated example. So part A, I have negative absolute value of 3x minus 4 equals negative 5x minus 12. Okay. So I want to begin by isolating the absolute value, getting it by itself. So there's this extra negative sign in front of it that I have to get rid of. So I can divide both sides by -1. So doing that, it gets rid of the negative on the left, and I'll get absolute value of 3x minus 4. And on the right, the negative is going to switch both of these negative signs on top. I'll get positive 5x plus 12. So now I have the absolute value of some stuff equals some junk. And when I reach that point, I get to split it into two cases, where the stuff inside, which is 3x minus 4, it can either be equal to the junk that's on the other side, 5x plus 12, or the stuff inside, 3x minus 4, could be equal to the negative of that junk. So when I write the negative of that junk, I gotta write negative, make sure I put a parentheses around the whole thing, 5x plus 12, to make sure I know that the negative applies to all of the terms in the parentheses. If I didn't have the parentheses, I'd forget that, wait, I gotta distribute it to both of these terms. Okay, well, so now I have these two equations to solve. All right, so in this first one, let's just rearrange terms a little bit. So I can move 3x over to the right, so that'll give me 2x. And I can move 12 over to the left by subtracting. So that'll give me -16. And then I divide 2 and I get -8 equals x. So in the other equation, I got 3x minus 4. Distribute the negative, -5x minus 12. I can add 5x to the left. So that's going to give me 8x. And then if I add 4 to the right, I'll get -8, and dividing the 8, I'll get x equals -1. So I'm getting these two answers at this point. And, perhaps you remember from like algebra class before that when I'm solving an equation with an absolute value, there's something I still need to do, which is check for extraneous solutions. I'm going to abbreviate solutions. Check for extraneous solutions. Okay, so I got to take these answers I'm getting, plug them back into the equation, and see if do they actually work. Okay, so with x equals -8, if I take that and I plug it back in, so I have to plug it back into a step where the absolute value is still there in the problem. So that could either be this original step right here, or it could have been this step, because an absolute value is still there at that point. But it cannot be like this step over here, because at that point the absolute value is gone. So I'm going to go ahead and plug it into this step. It just looks a little bit simpler to me than the first one, but I could also have plugged it into the first one. So if I plug it in, I'll get absolute value of 3 times -8 minus 4, absolute value equals, I'll put a question mark, because I don't know if it equals just yet, and then 5 times -8 plus 12. Okay, and if I simplify this, the right-hand side, I'll get -28 And at that point, I don't even need to simplify the left. I'll just write absolute value of some stuff. Because if I absolute value some whatever is inside, there's no way that can be equal to a negative number. So that's definitely not going to work. So as a result, I'll put a slash through this answer, and I'm going to write extr to abbreviate, and that means it's extraneous. Okay, so that answer didn't work. Let's try the other one. X equals x equals negative 1. X equals negative 1. I'm going to plug it into my equation. So I'll get absolute value of 3 times negative 1 minus 4 equals question mark, and then 5 times negative 1 plus 12. Okay, so if I simplify this, the stuff inside of this absolute value becomes negative 7. And then when I absolute value it, well, that turns into a positive 7. And on the right side, negative 5 plus 12, well, that's 7. Okay, so both of the sides are equal. So I'll put a check mark here. This one did work. Okay, so overall for this problem, there's just one answer. It's just x equals negative 1. The other answer was extraneous. So anytime I do have an answer that's extraneous, I definitely need to indicate that like I did here. Okay, alrighty, so let's take a look at another example. For this next one, I want to give you an opportunity to try this first. So pause the video for about 3 minutes to try this. That may not be enough time to finish the problem, but that's okay. I mostly want you to be thinking about, what are the key steps? How do we begin something like this? And try to make progress from there. 4, 3, 2, 1, pause it. Pause it for about 3 minutes to try this. All right, let's bring it back together. Let's talk about this. Alrighty, so I got this absolute value in my equation. The first step is I need to isolate it and get it by itself. So these other terms over here, I need to move them over to the right side. Okay, so I'll get absolute value of 3x minus 4, and then when I move terms over, I'll get positive x minus 3. Now that it's isolated, I get to do the stuff and junk thing and split it up. So the stuff inside, which is 3x minus 4, that could be equal to one of two things. So 3x minus 4 could be equal to one of two things. Either it's equal to the x minus 3 that I have on the right, or it's going to be equal to the negative parentheses of that x minus 3. Okay, so either it equals the junk on the right or it equals the negative of that junk. Okay, let's simplify each of these equations. All right, this one, I can move the x over and I get 2x. I can add the 4 over and I get 1. Dividing, I get x is 1/2. Okay, in my other equation, let's distribute the negative. So 3x minus 4 equals negative x plus 3. And then if I add x over, I get 4x. If I add 4 to the right, I get 7. And then dividing, I get x is 7 over 4. Okay, so I'm getting these two possible answers. All right, and now I need to check them. So I have an equation with an absolute value. I got to check my answers to see if either of them is extraneous. Okay, so I got, my first answer was x is 1/2. So remember, when I plug it in, I have to plug it into a step where the absolute value is still there. So that could either be this original step, or it could be this step. But it can't be anything after that, because after that, the absolute value is gone. So again, I kind of like plugging it into this step. It looks a little simpler to me than the original, but either way is totally fine. Okay, so if I do plug it in, I get absolute value of 3 times 1/2 minus 4, close it, equals question mark, 1/2 minus 3. Okay, so when I simplify this, I notice I'm going to have to get a common denominator on the right. So 3 is 6 over 2. So 1/2 minus 6 over 2, well, that's negative 5/2. So negative 5/2. Okay, and because that's a negative number, I don't even need to simplify this side, although I could if I wanted to. I can just write absolute value. I got absolute value of some stuff, but the absolute value of anything cannot be equal to a negative value like this. So I'll put a slash through the equal sign. Those are not equal. Okay, so that means this answer is extraneous. I'll put a slash through it and write EXTR, extraneous. Okay, so I got one more answer to check. So x equals 7 over 4. So if I plug that in, absolute value of 3 times 7 over 4 minus 4, question mark on my equal sign, and then I plug in and I get 7 over 4 minus 3. Again, I have to get a common denominator on the right. So 3 becomes 12 over 4. So now when I subtract, I'll get negative 5 over 4 on the right. So I don't even need to simplify the thing in the absolute value again. Yeah, I could if I wanted to, but I'm going to go ahead and just write absolute value of stuff over here. I don't even need to bother simplifying it because it cannot be equal to a negative value. So as a result, this answer is also not working. EXTR, it's extraneous. Okay, so that's a little weird, but that can happen. Sometimes all the answers that I end up getting from this process end up not working. And what that means is, well, there's no solution to the original equation. Alrighty. Okay, so let's flip the page here. Okay, so let's take a look at another example, but we're going to up the difficulty this time because we have something with two absolute values. So there's two absolute values in this next equation. Okay, so what I need to do first there is, well, isolate one of the absolute values. Isolate one absolute value first. So I could do either one. Maybe I'll isolate the absolute value of x plus 3. Doesn't really matter. And then the other absolute value I'll move over. So I'll get 6. And then this one has a plus in front of it. When I move it over, it becomes minus absolute value of 2x minus 5. And now I got absolute value of some stuff equals some junk on the other side. Now I'm going to split it up and do my stuff in junk thing. But I'm going to give myself more room here. And we'll see why in a sec. Okay, so the stuff inside, which is x plus 3, could either be equal to the junk on the right, 6 minus absolute value of 2x minus 5, or the stuff that's inside, x plus 3, could be equal to negative, big old parentheses, of that junk. So negative of the 6 minus absolute value of 2x minus 5. Okay, so now I have these two equations that I need to solve. Each of these equations is a little bit simpler now. They just have one absolute value in them rather than two. And, well, I know how to solve an absolute value equation. I first isolate the absolute value. So in this first equation, let's isolate the absolute value. Right now this is a negative in front, so maybe I move it to the other side. That'll make it a positive in front of the absolute value. And then this x plus 3, let me move it over to the right side. So if I subtract 3 from 6, I get 3. And if I move the x over, I'll get minus x. That's just from rearranging terms. Now this absolute value is isolated. So again, I get to do my stuff in junk thing. Where the stuff inside, which is 2x minus 5, it either equals the junk on the right, or the 2x minus 5 could equal negative, parentheses, that junk, the 3 minus x. Okay. All right, so now I need to solve each of these equations, but these are much easier now because the absolute values are gone. So this first one, let's see, I can move this x over to the left by adding. So I get 3x. I can add 5 to the right to get 8. Divide the 3, and I get 8/3. Okay, and this next equation, let's distribute the negative. 2x minus 5 equals negative 3 plus x. Then I can subtract x over to the left. So that'll just give me x. And then I can add 5 to the right, which will give me 2. Okay, so from this branch here, I am getting these two answers. But remember, I still have this branch over here to solve. So I'm going to just separate my work a little bit and draw a vertical line here. Okay, so again, I have an equation with an absolute value. I need to isolate the absolute value. First, let me distribute the negative sign to each of these terms. It's like x plus 3 equals negative 6. And then the negative will change that negative into a plus. Absolute value of 2x minus 5. Now I can isolate the absolute value. So I'll get absolute value of 2x minus 5 by itself. I will add 6 over to the left, and that gives me x plus 9. Now the absolute value is isolated, so I get to do my stuff and junk thing. So the stuff that's inside, which is 2x minus 5, it either equals the junk on the other side, x plus 9, or the 2x minus 5 equals the negative parentheses, all of that junk. Okay, all right, let's solve these. I move the x over and I'll get x, add 5 and I get 14. Okay, in the other equation, if I distribute the negative, 2x minus 5 equals negative x minus 9. I add x to the left to get 3x. I'll add 5 to the right to get negative 4. Then I divide the 3, and I'll get x is negative 4 over 3. Okay, so overall, we're getting 4 possible answers. Okay, and that was happening because I had 2 absolute values in this equation. Each extra absolute value kind of doubles the number of potential branches I end up with. So if I had had 3 absolute values in my equation, well, I would have ended up with 8 answers here at the end. Okay, so I'm not done yet, because remember, I got to check for extraneous solutions if my equation has an absolute value in it. So I'd have to check. And when I check, remember, I have to plug into a step where all of the absolute values are still in the problem. So that could either be the original, or it could have been in this step. Both of them are still in there here, but anything below that doesn't work because at least one of them is gone. Okay, so the check is just, a bit of arithmetic, and I'm going to trust at this point that, you're going to be able to do that. So what I'm going to say is I'm going to put a ... and I'm just going to tell you which answers don't end up working. It turns out that when you check them, 14 doesn't work. This is extraneous. As well as this negative 4 over a third. That's extraneous. But I got to plug them in and see if the sides are equal to see if they're going to work or not. Okay, so what ends up working is just the 8 over 3 and the 2. Okay, so that the actual check I am leaving it for you as an exercise, some practice. Okay. So what I want to end this video by kind of briefly discussing is why, when we have equations with the absolute values, why can they potentially give us these extraneous answers? It doesn't always happen, but it can. So why is that? So the reason for that, it's something very similar to what we saw with equations with square roots or even roots. It has to do with the fact that when we remove an absolute value, when we do that step, we are removing a restriction in the equation. Because when you have the absolute value of some stuff, the absolute value of some stuff has to be greater than or equal to 0. But when you remove the absolute value, well, that quantity, this stuff, well, no longer has to be greater than or equal to 0. It potentially could be a negative quantity. So it opens up the possibility then that we might get some extra answers that don't work. All of the situations where you potentially end up getting extraneous answers have something like this, where there's some restriction in the problem, like a square root or an absolute value, but you end up removing it through the process of solving, and that potentially can give you extra answers. Actually work.